So I'm going to close all these tabs. Now, if I go back to one of the services and the pipeline configuration, there is one thing that I mentioned, which is that we're repeating the same configuration or same pipeline configuration code for all the services. And this is one of the disadvantages of polyrepo, that you have a code or configuration that all services need, and you have to basically replicate it in each service because you have to have it in each project separately, like the Docker Compose file or the pipeline configuration. Now imagine we had a full CI/CD pipeline with multiple test jobs and deploying to 3 different environments. So our pipeline would be even longer and we would be repeating even more configuration code across our services. And if we had 10, 15 microservices, we would be repeating it 15 times. Plus, each service team would have to write their own pipeline and manage that. And with time, the release pipelines of different services may end up being completely different and inconsistent. So each service may be released with different tests, pushing to different Docker repository, and so on, instead of having a fully optimized, proper pipeline that all services can reuse. And that's not a very efficient way to work, right? So what is the best practice here and how can we optimize this? Well, for that, we have what's called templates and template library in GitLab. So what is that? If you have worked with Jenkins, it's basically equivalent to Jenkins shared library. So basically we take the common pipeline configuration. So this build job and this deploy job is the same for all services. So we are taking that common logic or common configuration, making it generic and reusable, and putting it into its own separate Git project. And any project that needs that configuration can simply reference it and basically fetch it from that separate repository. So we would have this logic once, or this configuration once, in this dedicated repository, and all the jobs or all the pipelines that need that configuration can basically pull it from there and use it. And by the way, we already saw an example of using job templates in our pipeline configuration. Remember the SAST job that we reused in our pipeline from the GitLab's managed repository, which we included using this template keyword? Well, in that case, we reuse the configuration template from GitLab's managed template repository. But we can write our own templates as well, or use templates from other teams, for example. This way, all teams can work together to develop this shared pipeline configuration, or you may even have a separate dedicated group of engineers in your company who will work on this task because they have the most expertise in that and know how to configure the pipeline with best practices. And then all the developer teams in the organization can simply reuse this configuration with very little configuration effort. This way, you can save your developers a lot of unnecessary time and effort, and you will end up having more consistent and standardized testing, building, deploying processes for your applications throughout your organization. So instead of everyone kind of putting together their own weird pipeline, you have one standardized pipeline or parts of the pipeline that everyone can reuse. And it's actually pretty easy to do on GitLab. Essentially what we need to do is we need to split our pipeline configuration and extract the configuration that should be shared into a separate YAML file. So starting in the front-end project, what we're going to do is we're going to extract all this common shared configuration into separate YAML files. And by the way, as a refresher, remember I mentioned that there are 2 types of templates in GitLab. So we have the pipeline templates for the whole pipeline. You don't have to write it from scratch. And the second one is job templates, which means that you have one specific job which is put into a reusable YAML file, and you can include that in your own pipeline. And one important criterion of templates is that they should be generic and reusable. And you can make them generic and reusable by making it customizable, meaning we should be able to pass any custom values or parameters to make this generic job specific to our project's needs. So for example, the deploy job can be made generic and customizable, so we can use it for different services and maybe also for different deployment environments and so on. So let's actually go ahead and see all that in action. And we're going to see that first with the example of the front-end pipeline. So I'm going to switch to the Web IDE mode again, open the pipeline code, and as I mentioned, we're going to split this pipeline and we're going to extract the jobs into job templates in separate YAML files. So I'm going to take this whole thing. In the project, we're going to create a file, and let's call this build template.yaml. And by the way, the name can be anything. It doesn't even have to start with dot. You can name it build.yaml or build-template.yaml, whatever you want. It just has to be a YAML file. In my case, I'm going to go with the dot so that all the dot files are grouped together. And I'm going to paste this build job in there. Now, as I said, template job has to be generic. So first, we're going to remove the front end here. And we can also remove the tags because we may want to run different jobs on different runners. So we may not want to hard code where the job will run, right? So I'm going to remove that as well. But this whole logic can stay because we have the same build and push process for all the microservices. So that's going to be generic, customizable build template for our services. Now, in order to customize this or make this generic build job actually do something specific for our front-end service, we need to pass in the parameters, right? And this will be the environment variables that we're setting here. Now we're using a mixture of predefined variables and variables that need to be passed in as parameters. So optionally, we don't have to do this, but optionally for a better overview of what variables we need to actually pass, we can list them right here, like this. So this way, when we use that job template in one of our project's pipelines, we know which variables are coming from the predefined variables, so we don't have to set them, and we know which ones we need to actually provide as parameters. Because if we don't, the job will fail, right? So you can list them for an overview, or if you want to use some default values in case nothing is passed. But as I said, it will work without, so you don't have to actually define them. In our case, we're gonna leave it empty. And now the question is, how do I include or use this build in my pipeline? It's actually very easy, and we saw an example of that. We import or include whatever is in this file into the pipeline using this include keyword that references the location of the file. So build template.yaml, and what this will do is basically tell GitLab there's this YAML file that has some build configuration. Please go fetch that, and whatever is defined here, make it available inside the pipeline. So we have the build job available in the pipeline. And now we will have to use the job or make it active. And we do that by referencing the job name. So it has to be build, whatever the name is defined here. And we can pass or we can set any additional configuration on that build job if we want to. In our case, we would need to set the tags to make sure it is running on our GitLab runner. And this will basically trigger the build job that is defined here with this logic. And all the values that we need to set, in this case, microservice and service version, are specified here. So these values will actually be applied to the build job that we include here. We don't have to pass them as job variables. They will be applied from this variable configuration. And you can have this include at the beginning of the file or at the end, it doesn't matter. We're going to put all the include statements at the beginning. And in our case, because we have this YAML file or this job template locally in the same project, we can actually use a keyword called local to tell GitLab that we're referencing our local job template. So local is another keyword that we can use inside include. And the first one that we used was template, which referred to GitLab managed repository templates. And by the way, this type of splitting your configuration can even be useful if you have a huge pipeline code for one specific project that you want to better organize and split into multiple YAML files. So instead of having one pipeline with 100 lines, you can actually extract some of that into own YAML files in the same repository and include them like this. And you can even have a templates folder where you put all these template YAML files and basically manage your pipeline code more cleanly. Now, one interesting thing to note about job templates is that if I needed to add some custom configuration in the before script or script section, so for example, in the before script, I wanted to change into a different directory and export some other variable like this. So basically having this kind of logic, but I wanted to pass that additional logic from my specific job implementation, right? So I wanted to do something like this in order to add that custom configuration on top of what's already configured in the job template. So in this case, what this configuration will do is it will actually overwrite with these two lines whatever is defined in the build script. So it's not additive. It's not going to add these two lines in addition to those two lines defined already here. It's actually going to replace them. So you will not have this code available anymore. So if you wanted to do that, or if you needed to do that in some case, then you would actually have to provide the whole configuration in your specific implementation of the job and pass the before script like this, using whatever is defined in the template already, plus your own custom configuration. So that may be an interesting thing to know about this feature. So let's remove that. And since we have the build already extracted, let's go ahead and do the same for deploy job. So I'm gonna grab this whole thing and create another template job for deploy. And let's call it deploy template.yaml. Paste it in here. Again, everything is already generic. So if we had some hard-coded values inside, we would have to parameterize them and make them customizable. But in our case, we already did everything with best practices, so we don't have to change anything. But we will remove the text here as well, because again, we may want to run them on different runner. And the same way, we're gonna include that using include local, referencing the file, and we're gonna make the job name also generic, and we're gonna execute or include the job right here. And there you go. That's how you extract jobs into job templates, by making them generic and reusable and include them in your pipeline configuration. Awesome. So now let's actually validate that the front-end pipeline still works as before. So we're going to commit those changes and let the pipeline run and deploy our front-end service. So our pipeline for the front-end service has passed. Let's now just validate that the front-end service is up and running and everything works as before. Now we have created job templates from our pipeline configuration, but we would need these build and deploy templates for other services as well to include them in their pipeline configurations. So of course it doesn't make sense to keep them here in the front-end project. So let's create a common project for our services and call it CI templates. And you can create this project outside the group if you want to. In our case, we're gonna share this configuration among our microservices. So we're gonna create this also inside the group. So I'm going to create a new project. Let's call it CI templates. Make it public. And what we're going to do is basically take those two YAML files and move them here. So we're going to have build and deploy YAML files, and let's actually call them build YAML and deploy YAML to make it simple. And let's copy the code from here. So we're not changing anything, we're just taking that extracted job template and we're putting it into a separate repository. And that's it. Let's commit this. So the CI templates registry is available, and those files can now be referenced by any project inside the group, or basically any project in your GitLab instance if you have permission to use that templates project. And this means we can delete them from here. So let's do that. And now the question is, because we don't have them available locally anymore, how do we reference YAML files or template job files from another repository? And for that, we have another keyword instead of local. So let's actually delete this one. And that is project and file in the project. So now we're telling GitLab that we want to include a YAML file from a project called CI templates, but we also have to specify in which GitLab instance or GitLab group that is. In our case, we have the project inside the group, so we have to specify the group name, which is my microservice -CI/CD. So let's do that, my microservice -CI/CD /CI templates. If you have CI templates project outside a GitLab group, then instead of the group name, you will have to specify your GitLab username, like this. So that's the reference to a project, but we also want to tell GitLab which files from that templates project we want to include, because you may have 100 template files here that all the developer teams in your organization use, so you have to obviously specify which files specifically you want to include in your pipeline. So for that, we have another attribute called file, and this actually can be a list. So we're gonna list these two files here, so build.yaml and deploy.yaml. And another attribute we can use is what's called the ref, and this references either a branch in that project or a specific commit hash or also a tag. In our case, it's the main branch, so we're gonna specify that. And we actually don't need the quotes here, we can remove them. And that's it. This will give us those two job templates that we previously had available locally, and nothing in this configuration will have to change. Now let's again validate that this works by committing and running the pipeline and making sure it still works. So going to front end, CI/CD pipelines, and let's wait for this to finish. And our pipeline has been successful. We can also make sure that the front-end service got redeployed. It says 59 seconds ago, so that was our deployment. So referencing the CI templates repository is working. So by extracting those jobs into job templates, we actually managed to slim down our pipeline configuration to these few lines of code. So we have a very simple configuration. We're basically just setting some specific values, and that's it. So I'm going to copy this, and we're going to go to other two projects and make their pipeline configurations also this simple by reusing our job templates. So I'm just going to paste it in. This will stay the same, this will stay the same, and those three values will be changed. So it's the products service 3001. We could actually export those two variables in our CI template because we're not changing them for our services. Let's actually go ahead and do that. We're going to add them in the deploy job like this. And you can actually override these variables from the specific project's pipeline. So this will be like the default values for these variables that you get in the job template, but you can override them obviously. So let's commit that. And now we don't have to reference it here. But as we did in front-end service, we could still set them. So this would be the products service pipeline. Let's actually commit that and deploy the product service. And while this is running the pipeline, let's go to the shopping cart and change the pipeline configuration here as well. Let's paste it in. And again, setting the variables, shopping cart 2.1 and port 3002. And let's commit those changes as well. And pipeline in progress. So let's wait for those two pipelines to complete successfully to make sure that our configuration works for all the services. And as you see, both of our pipelines have passed successfully. We have the shopping cart and product services, and we can also validate that here on the host directly. Products has been restarted 5 minutes ago and the shopping cart 29 seconds ago. Awesome. So we have created pipeline configuration for our polyrepo project using the best practice of extracting the common code, putting them into what's called template library that has multiple job templates, and then referencing them in your pipelines as you need them. And we saw that referencing is done using this include keyword. And if we have local YAML files, we can reference them using the local keyword. If we're referencing a CI templates project from our own GitLab instance in our organization, then we can use this project and file attribute. However, there could be cases where you want to reuse templates or job templates from another organization's GitLab or maybe some public GitLab repository with job templates, in which case you would need to use another keyword, which is remote. And the value of the remote will be any URL that references that YAML file. So something like this, for example, on a GitLab, somebody else's project and their job template. Or this could also be an endpoint of a storage that basically holds your job templates, right? You may be using S3 bucket or some kind of other file storage that holds some GitLab CI/CD pipeline configuration files. So they're not a GitLab project, they're some storage endpoint, which you can also reference using this remote keyword. And as we saw on the very first example of include, you can reference any templates that are managed by GitLab itself using the template keyword. So this is specifically reserved for templates of GitLab. We saw an example of SAST. This could be another example. So in this case, instead of having to reference that GitLab's managed project using the URL, by using the template keyword, GitLab knows that it is referencing that official template repository of GitLab, so you don't have to specify the full path. You just have to specify either a directory inside the project or directly the file in the root folder. And this include example that you see here with multiple types of includes is actually an absolutely valid include syntax, which means you can include YAML files or configuration files and job templates from multiple different sources, different types of sources, and you can basically mix it up, right? So we can have some local reference as well, and you can have multiple references of the same source as well. So you can have a mix and combination of these different types of sources for your include files. So let's clean this up. And that's the end of our microservice pipeline configuration that deploys to a simple EC2 service and runs services as Docker containers. In the previous chapter, we learned about microservices, and I mentioned that microservices architecture has multiple benefits compared to monolith applications, and it has pretty much become the standard today. But we also said that these benefits come with a huge complexity, and one of those complexities or challenges is running the microservices. We just saw deploying the microservices application with Docker Compose example. But in real projects, running and managing large microservices applications with just a simple Docker Compose can be really hard and challenging, especially if you want to scale your services, like run multiple instances of each microservice, or if you end up having hundreds of microservices for your application. You will start having challenges like not knowing when a microservice is down, having to manually restart services and their instances when they fail, or getting unexpected results when one microservice is down or unhealthy, etc. So managing running microservices may become very challenging without a proper mechanism in place. To give you an example of the extent and size of some microservice applications, Netflix, for example, has hundreds of microservices and hundreds of thousands of instances for these services. So if any of those instances is down, how would they know? They would need to have some kind of a system to monitor all of these microservices and the instances running in a deployment environment. Amazon, Google, they have even more microservices. So how to manage running such complex microservices applications? Well, here as well, there are tools to solve these challenges. And that's where the container orchestration tools come in to provide features to handle exactly those challenges of running microservice applications. With container orchestration tools, you can flexibly scale up and down the instances. For example, if the application is under heavy load or heavily used during the weekend, you can schedule 100,000 more instances during the weekend and remove them or kill them all by Monday. And all of this will be an easy process with a container orchestrator with no effect on the overall application. You can even automate scaling up and down during certain times, which can be super efficient when you have to manage hundreds of thousands of instances. And even if a microservice is down or it fails because of an error or something, the orchestration engine can automatically restart it. Again, you don't have to detect which instances are down and restart them. It all happens automatically. And there are many other benefits as well that such orchestration tools provide when running microservices applications. And one of the most popular container orchestration tools today is Kubernetes, which means when you're working with microservices, you will most probably also be working with Kubernetes. So when building CI/CD pipelines for your services, you would need to know how to deploy your microservices application to a Kubernetes cluster. That's why in this final part of the course, we're going to use Kubernetes as a deployment environment for our microservice application. Now, we're not going to go into details of Kubernetes and how Kubernetes works because that's outside the scope of this course. I have separate videos and separate courses about Kubernetes because it's its own huge topic. What we will focus on is how to deploy from GitLab CI/CD pipeline to an already running Kubernetes cluster. But I have to mention here that you do need some basic prerequisite knowledge of Kubernetes in order to be able to follow this. You need to know some basics like what a service or deployment is or what a Kubernetes manifest file is, etc. And if you don't have those basics yet, I suggest you watch my Kubernetes prerequisite 1-hour crash course, which is linked in this video. The course will give you all the basics you need in order to follow this specific demo. So in this part, we're going to see how to take our microservices application and deploy it to the Kubernetes cluster. For that, of course, we will need a Kubernetes cluster, so we will create one. Once we have the cluster, we will create a dedicated user in Kubernetes for GitLab. So GitLab can connect to Kubernetes and deploy applications inside. And finally, we're going to configure our microservices pipelines to deploy the service to Kubernetes cluster by creating deployment and service components for the microservice. So let's get started. So first we will create a managed Kubernetes cluster on Linode platform. I chose this because it's easy and takes just a few minutes to have a Kubernetes cluster up and running in a somewhat production-like environment, but you're welcome to create Kubernetes cluster anywhere else you want, or even use a local Kubernetes cluster with Minikube or some similar tool. Because our demo is not specific to Linode's managed cluster, this should work for any Kubernetes cluster. I'm going to go ahead and create a Kubernetes cluster on Linode. And if you want to follow along with me and create a cluster on Linode, you will need to sign up for an account, and know that they have, for the first creation of the account, they usually offer this $100 credit. So make sure to take advantage of that. This way you can save costs on running a Kubernetes cluster on Linode. So make sure to sign up with the deposit. I already have an account, so I'm going to log in. And it's super simple. On the dashboard, I'm going to go ahead and create a Kubernetes cluster. Let's call this my microservice and select the region which is closest to you geographically. So the cluster worker nodes will be running in that region. Also select the latest Kubernetes version, whatever is in the dropdown. And right here is where we select the worker nodes. Now we are gonna do very simple, minimal deployment. So let's go with the smallest servers, so to say, and 2 of them will be enough. 2 of the smallest nodes, I'm gonna add them and create the cluster. That's it. This will now create a cluster in a couple of minutes. So we're gonna wait for that, and we're gonna have an up and running Kubernetes cluster available to deploy our applications to. So this will take a couple of minutes, like 5 to 10 minutes, until your cluster nodes are in the running status. You see a Kubernetes API endpoint here, and you also have this downloadable kubeconfig.yaml file. Now, when we create a Kubernetes cluster, an admin user, a default admin user, usually gets created automatically for the cluster. So that when we use kubectl commands, we can access the cluster and administer it using that admin user. But how do we tell Kubernetes, or how do we tell kubectl that we're using that Kubernetes admin user? If I just do kubectl, like any kubectl command, obviously it doesn't know which cluster you want to connect to, which user to use, and so on. Well, for the admin user, an access file, also called kubeconfig file, also gets generated. So this is the file that has all the information about the cluster location or cluster endpoint of the API server, as well as all the credentials for the admin user and so on. It has all that inside, and we need to pass that file to our kubectl command so that it knows how to connect to the cluster. So we're going to download this kubeconfig file just by clicking on it on this Linode's managed Kubernetes service, which is pretty convenient. And it's actually just a YAML file with some information. We can even look inside if I cat this. So essentially, this is a Kubernetes access file that contains authentication information for the admin user. It has information about the cluster endpoint right here. So that's the address which the cluster is accessible at. So this is going to be the API server endpoint. Then we have the cluster certificate right here, the certificate data. This ensures that the access file was generated and signed by our cluster certificate and not generated by some random source. So you can't actually easily manipulate it. Finally, we have the user and its credentials here. So that's an admin user. This is the name of the user, and you have the credential or access token for the admin user. And all this was generated automatically. In Kubernetes, we have what's called service accounts, which represent usually a non-human user. And the service account has an access token, the one you see here, so it can authenticate itself with the cluster or with the API server when it connects to it. And the service account also has some permissions. What is it allowed to do inside the cluster? Obviously, the admin user has admin privileges, so it can administer the cluster, meaning you can access all namespaces, create, delete, update, all kinds of components in those namespaces, etc. So we're going to use this kubeconfig file to access the cluster. However, since this file has some sensitive information inside, we will need to set limited file access permissions to it first before we can use it, which is just a security measure. We actually did the same on EC2 instances private SSH key to be able to SSH to the servers. So that's the same thing here. Let's quickly do that. So we have this admin user and its access file, which we can now use to connect to the cluster and administer it. And as I said, since we're accessing the cluster using the kubectl command, we would have to pass this file to the kubectl command telling go do this in Kubernetes cluster using this info in the kubeconfig file. And one of the ways to pass the kubeconfig file to this kubectl command is by exporting a variable called kubeconfig and setting it or pointing it to the kubeconfig file. And now kubectl will actually read whatever the value of that variable is and use that file to access the cluster. So if I execute cluster info, now we should be able to connect to the right cluster and get the information from it, as well as authenticate with it. So this environment variable basically tells kubectl where to find the kubeconfig file, or if you have multiple kubeconfig files, which one to use. So now we can execute any kubectl command against the cluster, and we will be able to do anything that an admin user that is defined in this kubeconfig file is allowed to do, like get the namespaces, create, delete, update stuff, and so on. Now, kubectl is a command line tool, right, that you install on a server, on a local machine, whatever. And we can execute it from anywhere where you have kubectl installed, from our local machine, but also from GitLab runner's machine. It's the same thing. So if we took the admin user's kubeconfig file and gave it to the GitLab runner, we would be able to execute commands and deploy applications from GitLab runner to the cluster, as long as it has this kubeconfig file. But let's think about this. Do we want to give GitLab an admin user's credentials? What does GitLab need to do in the cluster? It needs to create a deployment and service resources in a specific namespace, right? Maybe also create config map and secret for the application that is deploying. But that's it. It surely doesn't need to administer anything in the cluster or have access to the system namespace like the kube system, for example. And the security best practice is you should always give each user only the privileges it needs and not more. Because if someone hacked into your GitLab, they would have full access of your cluster and they will be able to do a lot of damage with it. So we're going to do this according to Kubernetes security best practices for CI/CD pipelines and create a dedicated service account for GitLab and give that service account only those permissions that it needs to do its job. We will then generate the kubeconfig file for that service account and give GitLab that kubeconfig file to execute kubectl commands with it. And it's actually easier than it sounds. So Kubernetes administrator will have its admin user and GitLab will have its GitLab user. So as an admin, let's create a GitLab user with needed permissions. And in our case, we're going to be deploying our applications in a dedicated namespace. Let's call it my microservice. So we're going to give GitLab permissions to that namespace. So first, let's create the namespace itself using a simple create namespace command. And let's call it my microservice. And now if I do get namespaces, we have that namespace right there. Cool, we have a namespace. Now let's create a service account for GitLab. It's also very easy. We have a simple kubectl create service account command. And by the way, all these commands and all these files that we're going to use here are in the Git repository, so you can check them out there and copy them if you want to. So we're creating a service account. The name of the service account, we can call it CI/CD service account or GitLab service account, doesn't matter. I'm actually gonna call it CI/CD to keep it generic. And we're gonna create that service account for the namespace my microservice. Like this. Let's wait a little. There you go. We have service account called CI/CD SA. Now this service account needs some permissions, right? It needs to be able to deploy, create some stuff inside the my microservice namespace in order to deploy our microservice applications. In Kubernetes, permissions are given using resources called roles. So as the next step, let's create that role. And we're going to create that using a Kubernetes YAML file. And let's call it CI/CD role.yaml. Again, you will find this file in the Git repository, so you can just copy from there. And I'm going to paste in the role configuration. So very simple YAML file. You have the resource, which is role. We're creating a role for my microservice namespace. This is the name of the role. We can call it CI/CD role. And these are the actual permissions in the cluster. So basically what we're saying here is that whoever is having this role, whoever user or service account has this role associated to it, will be able to get, list, watch, create, update, patch, delete. So this is basically the full, complete list of everything that you are able to do, pods and services. So they will be able to do anything with these two resources. So we're going to be creating services and pods with GitLab, and we're also going to be creating deployments and updating deployments and maybe getting the deployments. So we're going to be able to basically do anything with these three resources in GitLab with this role. Now you can also limit this and say that it's not allowed to delete anything, so you can remove the delete, but I'm going to keep it like this, full permission for those three services only in the namespace my microservice. So this role doesn't have permission to see any other namespaces, to see any other resources, or do anything in other namespaces, which is already a very good limitation. So I'm going to save this, and we're going to apply this file using kubectl apply and the file name. There you go. The role was created. Now, as I said, we have the service account role. We have to associate them together or link them together so we know that this service account has this role. And for that, there is another resource called role binding. So we're binding this role to the service account because obviously you can have one role and you can use it for multiple users or service accounts, like developer role, and then you can give it to all the developers in the team, or have a senior developer and junior developer roles, whatever. So create role binding, and I'm seeing the command completion here because I have executed this command already. So this is from my history. So role binding needs a name as well, and we're going to call this CI/CD role binding, and we're going to pass this command three options. One, we need a role that we're binding. Second, we need the service account that we're binding to, and third, a namespace. So let's set those values. Very straightforward, actually. So we're binding the CI/CD role to the service account called CI/CD SA. And we're doing this for a namespace my microservice. And we have an error because in the service account, we also have to specify the namespace. So I'm going to copy this. And at the beginning, before the service account name, we're going to do the namespace name colon service account name. And let's execute. There you go. We have a role binding, which means our service account has a role associated to it now. So we're going to be able to do some stuff when we use that service account. Cool. Now that we have the user or service account for GitLab, we're going to create the kubeconfig access file for that service account. For that, we can simply just copy the admin kubeconfig file and replace all the relevant values with GitLab's user and service account token. So I'm going to copy the kubeconfig file and let's call this CI/CD kubeconfig.yaml. And we're going to need to replace some values. And let's see what we would need to replace. So basically the cluster information will stay the same because we're connecting to the same cluster with the same name and the same cluster certificate. The part that we will replace is the users because we have a new user with a different token and we're going to update this here as well. Now the question is, how do we get the token, this access token of our CI/CD service account user? Very easy. Let's do get service account in the my microservice namespace. And this is our CI/CD service account. So what happens is whenever we create a service account in a cluster, an associated secret resource gets created, and the secret holds the token. So the service account resource itself doesn't have the token, the access token directly, because it's a secret. So it's saved separately in a secret component and it's just referenced inside. And we can see that actually if I do get service account CI/CD SA, and if we get a full YAML output right here, it doesn't have the token directly inside, it just references the secret that has a token. So we're going to grab that and we're going to do get secret with this name inside my microservice namespace and get a full YAML. Because secrets are actually not encrypted by default in Kubernetes, we're going to see this base64 encoded value. That's our token. So that's the secret token or access token of the CI/CD user. So I'm going to copy that and basically decode it. So do echo, paste in the whole token, and we're going to pipe that through base64 decode command. And there you go. So starting from here to the %sign, you can copy this whole thing and that's our token. And now we can go into kubeconfig YAML file. The clusters section stays the same as I said. We're going to change the token part. So what I'm going to do is I'm going to delete this whole line, the token, and create it again like this and paste the value that I have. So we have a new token. Let's change the name to CI/CD. This is the name that you can define yourself. It doesn't have to be the service account name. This is just the name that you use as a reference inside your kubeconfig file. So we can call this whatever, it doesn't matter. Let's keep the index and just add CI/CD. So the user details are updated. Now let's go to the contexts and update the user here as well. So user and CI/CD instead. So that's it. This will give us an kubeconfig file for a CI/CD service account. So I'm going to save this. Let's actually overwrite this and there you go. So we have a kubeconfig file for our CI/CD service account with the right token. Now we can actually test that the user's access works in the cluster and it has the right permissions. And it's not allowed to do things that we didn't give it permission to do. And to test that, right now our kubeconfig environment variable points to the admin user's kubeconfig. We can override that and we can point it to CI/CD kubeconfig instead. Very easy. And now if I do get namespace, for example, I should not be able to do that because I don't have a permission to do it, forbidden. However, if I do get pod, for example, in my microservice namespace, I should be able to do it. We don't have pods inside, so we get no resources found, but the command works. We can also do kubectl get service, and there you go. So it gives us forbidden if we're not allowed to execute a command, and it gives us a response if we are allowed to do that. Let's also try to, for example, get pods from another namespace like kube system, for example. And here we should get forbidden again because we're not allowed to do that. Awesome, so the kubeconfig file works, the permissions are set correctly, and we have a GitLab user. And we have a CI/CD user configuration inside our cluster. Now we can just take that kubeconfig file and make it available for our pipelines in GitLab, and we're going to be able to execute kubectl commands in those pipelines. And this is going to be a file that all the services will need because we're going to execute the same kubectl apply command for all the services. So we're going to create a shared variable in the CI/CD settings, and as an alternative to SSH private key, we're going to create here an Kubernetes deployment file. Let's call this kubeconfig or kube_config, and this is going to be a file, and we can basically just take the contents and paste it inside. So I'm going to take all of this, copy, and there you go. Make sure the indentations and everything is correct, so I don't have any weird indentations here. And let's add the variable. Cool, so we have our kubeconfig file available for all our pipelines. Now let's configure our pipelines.